you want to be done not. And we will always do things that are a little bit more fun, a little bit out there. All right, so we have been doing triangles, right? And we have been using calculators. What if I told you that you do not need to use a calculator? But it doesn't always work though, but it does work for a very, very few specific angles, okay? Here, let's talk about this. It's basically trig, it's sine, cos, tan, but now we're gonna ditch the calculator for a bit. So there's something that's called special triangles. And why are they special, you might ask? Is because the ratios of these triangles, we don't need to use a calculator to find the angles. There's two of them, okay? There's two of them. Let's start out with the first one. The first one is called the 30-60. This is a right angle triangle. If this side is 30 degrees, what's the this side's angle?
60.
Correct, 60. Okay, 60. So for this triangle, we're gonna come up with its side lengths, okay? Now just bear with me. If I told you sine is equals to opposite over the hypotenuse, and that the value of sine 30 is equals to 1/2, would you be able to tell me the side lengths of this triangle? So look at it from 30 degrees perspective from here, okay? What's the opposite side? It is a 1. You see that? What's gonna be the hypotenuse?
2.
2. What's gonna be its adjacent? And don't tell me 1.
I don't know.
Use Pythagoras theorem. It's a right angle triangle. We know the hypotenuse, we know the opposite. We know C, we know A, we're trying to find B.
Oh.
Right, so A squared plus B squared equals C squared. That means B squared is C squared minus A squared. C is 2 squared, so 4. A is 1 squared, 1, and then we square root this. This is √3.
Okay.
See that? So the side length of this triangle is what? √3. You get that? Again, this stuff we have done, right? It's just SOHCAHTOA and Pythagoras theorem. Nothing too fancy going on. But now this is very, very powerful, this triangle. We don't need to use a calculator for some of these angles. Sine 30, well, we knew this. This is how we build our entire triangle. That's 1/2. What's cosine of 30? Just use SOHCAHTOA. Adjacent over the hypotenuse from 30 degrees perspective. So from this side, what's its adjacent?
Is it 3?
Yeah, it's √3, right? Not just 3, √3. What's the hypotenuse?
2.
2, there we go. So cosine of 30 is √3/2. You see that? What's going to be tan of 30? Again, just SOHCAHTOA.
The √3/60?
No, tan 30 is going to be opposite, right? You can look at it from this perspective. Opposite over the adjacent. It's going to be 1/√3.
Oh, okay.
You see that? Now we're going to flippity-flop. We're going to look at it from 60 degrees. What's sine of 60? Look at the triangle. Again, it's opposite over the hypotenuse, but you got to look at it from 60 degrees.
The root of 3 over 2.
Yeah, yes, perfect. Root 3 over 2. What's cosine of 60?
Um, 1 over 2.
Good. What's tan of 60?
Root 3 over 1.
Yes, so we can just write that as root 3, and there we go. You see, for these ratios, we don't need to use a calculator, because if you were to use a calculator, except for the halves, the other numbers, they never end. What are those numbers called? Called irrational.
Okay.
Like pi never ends. It's an irrational number. So you'll never, so these are called the exact values. Calculator won't give you this. This is the exact value of cosine 30, tan 30, sine 60, yada, yada. Calculator will not give you. If you just plug in sine 60, it'll give you 1 point something. Not 1 point something, it's going to be 0.8 or whatever. And it never ends. That is not the exact value, right? So if you don't use exact value, what happens? There's a little bit of an uncertainty, there's a little bit of an error term. And we don't want error terms in real life, do we? Even that small bit. Our goal is to eliminate errors, especially if you go into like these sorts of fields. Like if you're a doctor, you don't want to make any errors. Or if you're building a bridge or a building, no errors, or minimize the errors. Obviously, it's not going to be foolproof, but you want to minimize the errors. That's why we use exact values in real life. That's one triangle. Let's build another triangle. And again, the idea is very simple. It's just SOHCAHTOA and maybe Pythagoras theorem. Here's another triangle for you. And this one is called a 45-45 triangle. What is this type of a triangle called? There's 3 types of triangles, right? There's equilateral. There's like scalene, which means none of the sides are equal. When 2 sides of the triangles are equal, what is that called? There's a name for it. It starts with an I. Isosceles, okay? This is called an isosceles triangle. Isosceles stands for 2 sides of the triangle being same. In fact, this is called a right-angled isosceles. Now, isosceles by itself looks like this. One good property it has is the angles down here will be the same. Okay, keep that in mind. The angles, the bottom 2 angles of an isosceles triangle is going to be the same. That's why this one's 45-45. That's for another time. That's when we do the geometry unit again, or something that we'll see. So in this triangle, if this side is 1 unit in length, what's going to be this side's length?
Also 1.
Yes, good. Now the question is, what is going to be the hypotenuse? And it is not going to be a 2. It is not 1. It's not 2. Can you tell me what the hypotenuse is? You get 10 points. Use Pythagoras theorem.
Is it the root of 1?
Not the root of 1. Nope. Root of 1 is just 1, so it's not the root of 1. It is just Pythagoras theorem. And it cannot be the root of 1 because the hypotenuse always must be the longest side of the triangle. It can't be equal in length.
Is it the root of 2?
That's exactly what it is. It's the root of 2. Okay? Like that. Now from this triangle, it doesn't matter which 45 you look from, they'll both be the same. What's sine of 45?
1 over root of 2.
Good. 1 over root of 2. What's cosine of 45?
1 over the root of 2.
Good, 1 over the root of 2, yeah? What is gonna be the tan of 45?
Um,
Tan of 45.
1 over 1.
Correct. So there's a 1. Cool.
Mm-hmm.
So these are called the ratios of the special triangles, okay? You don't need a calculator for this. Let me show you why this is equal, because this is a little bit weird, right? How did that end up becoming equal? I don't know if we ever talked about this. I think we may have, but you probably did not or do not remember. What exactly in the world is sine and cosine? Well, they're functions, okay? They're functions. We'll get to them when we eventually get to them. They look like these squiggly lines that never end. But more importantly, they represent something. They represent, you see this is a circle that has a radius of 1, okay?
Mm-hmm.
Sine and cosine, they represent this point right here. You see this point is some point x comma y, okay?
Uh-huh.
And this is some angle. In our case, it's 45. So if you have a unit circle, okay? If you have a unit circle, that means it's a radius of 1. If you draw a 45-degree line, this point right here is what? Sine 45, 1 over root 2, comma 1 over root 2. It
Mm-hmm.
basically gives us the point on that thing. We saw at 30 degrees. At 30 degrees, what's this point? And by the way, it's a little bit weird here. X is given by the cosine value and Y is given by the sine value. So we saw before sine 30 was 1 over 2 and cosine 30 was root 3 over 2. That means at this 30 degree, okay, now this is 30 degrees. That's gonna be, that point there is root 3 over 2, comma 1 over 2. Exactly. Okay.
Mm-hmm.
So sine and cos, they also give us the points on the circle depending on what the angle is. And eventually we will be able to tell, like at maybe 330 degrees, what's this point? And that's the end game, okay?
Mm-hmm.
The end game is at 330 degrees. What is this point? We know it's gonna be some positive x and negative y, but we don't know what it is yet. We will eventually figure that out. So that is how you build the special triangle, and you should be able to do that by hand, okay? But for here, for the purposes, because I don't want to build it each time, I'm just gonna pull up a table in which they've already given us the values. Right here, this one. So this is what we just built, if you remember. So how do you read this? It means sine of 30 is 1 over 2. Tan of 30 is 1 over root 3. You see that?
Mm-hmm.
That's how you read this table, and they would expect you to draw this by hand, okay? But for the purposes of this lesson, because I don't want to draw it for each question and erase it, we're just going to keep this on the side here, and we just drew it. Now let's see what kind of questions they can ask you. By the way, before we do that, you need to be able to do something like this. What is root 2 times root 2? What do you think? No calculator required.
Is it root 4?
Which is? It is root 4. What is root 4 equals to?
2.
2. So basically root 2 times root 2, if you have the same numbers, the roots cancel out, okay?
Mm-hmm.
There's another question. Root 2 times root 3.
6.
Root 6. Okay, the root doesn't cancel out in this case.
Okay.
Okay, so root 4 times root 8 would be root 32 and yada yada. So keep that in mind. It only cancels out if it's the exact same number. It needs to be the exact same number. Let's look at this question. Determine the exact value of this. Now, Can you plug this in a calculator? What do you think?
Yes.
Why don't you try it? Why don't you plug this in a calculator and tell me what you got? What does that give if you plug it in a calc? No, nothing?
Like 0.9 something.
Right. Is that an exact value? Does it end? How many decimal places? Probably 8 decimal places. You don't know if that ends, and I will tell you it never ends. Now, is that an exact value? It is not, okay? It is not an exact value. Exact value means you need to give it exactly. And you see the table on the right. We're going to use to decipher what the exact value is. Check this out. Sine 45 is sine of 45. That's 1 over root 2, yeah? Times cos of 45, 1 over root 2 as well. Plus sine of 30, that's 1 over 2. What's sine of 60? Root 3 over 2. See that? What is 1 over root 2 times 1 over root 2? No calculator allowed. In fact, let's just say no calculator allowed. You don't need one. You shouldn't need one.
2 over root 2.
No. 1 times 1 in the, again, you just multiply the numerator with the numerator. 1 times 1 is a 1, right? What's root 2 times root 2 in the denominator?
Root 4.
Yeah, which is just a 2, right? So 1 over root 2 times 1 over root 2 is just 1 over 2. You understand? Plus, again, here we're just going to multiply the numerator with the numerator. 1 times root 3 is just root 3. 2 times 2 is a 4, right? Now, do they have the same denominators?
No.
No. So we're going to take the lowest common denominator, which is a 4. So we need to multiply this and this by 2. So we have 2 over 4 plus root 3 over 4. That'll be 2 plus root 3 over 4. And there you go. That's the exact value.
Okay.
Okay, you don't need a calculator to do this part. In fact, you're not gonna need a calculator. As long as you have the table on the side and can do some algebra, you should not require a calculator for this. It's also given in the book, but these values are not exact, okay? Because they never end. Let's see which one we can do. Let's do a quick word problem. Let me erase this. So there's a step ladder, there's a ladder propped against a classroom wall. So let's say this is the wall, this is the floor, and there's a ladder propped up against it like this. This is gonna be right angled. And the angle that forms is 30 degrees and the wall is 5 meters high. How far is the top of the ladder from the floor? So which side length are we looking for? AB is the ladder, okay? They want the distance, how far is the top of the ladder from the floor?
BC.
AC, correct. So what are we given in this? Again, look, you got to look at it from the angle that's given. Are we given O, A, and H? Which one are we given? And which one are we looking for?
A is 5.
A is not 5. AB is 5, which is the hypotenuse. Right? Which one are we looking for? We're looking for the O or the A? O or A? We want the distance from the floor, distance of the floor, right? We're looking for A, the adjacent, which is AC, correct?
Mm-hmm.
We're looking for this distance, right? We're looking for distance. We don't know O. We also do not care about the height of the wall, so we can just get rid of that. Which ratio uses A and H? Cosine, exactly. So we have cosine of 30, yeah, is equals to the adjacent, which is AC, divided by the hypotenuse, which is 5. How do we solve for AC?
You multiply 5.
Correct. So cosine of 30 is root 3 over 2, yeah?
Mm-hmm.
Times 5 is equals to AC. What is this? Root 3 over 2 times 5.
Do you put a 1 in the denominator for 5?
Yes, you do. You do.
The common denominator is 2, so you multiply by 2.
No, that's when you don't take the common denominators when you are multiplying, right? That's only if you're
okay.
subtracting or adding. That's the only time you want to use common denominators. No other time would you use common denominators. So in this case, you just multiply the numerator with the numerator. Don't plug this in a calculator because they want the exact value. So AC is always going to be root 3 times 5 over 2, like that.
Okay.
Okay, now here's 10 points for you if you can answer this question. What assumption did you make to solve this problem? I'll give you a hint to look at C. Look here.
It's a 90-degree angle.
Right. We assume that the wall and the floor are perpendicular to one another. Okay.
Oh, okay.
That's the assumption. Otherwise, we could not have used SOHCAHTOA. We can ignore that bit. Actually, I don't know. I don't know if you are ready. Let's try a couple of more and then I guess we can try that. We're gonna do this bit. And the notation, let's talk about the notation. Again, the one here is just a follow-up. If you have something like this, okay, you see tan squared 30? That's how you read it. That's the same thing as tan 30 whole squared. Okay, look at the notation. Like x squared is just x squared, right? But in trig, you would have something like sine squared x, which is the same thing as sine x whole squared, okay? So the squared means it's tan 30 whole squared. Cool? So let's do this. What's tan 30?
0.5.
No. You forget about the calculator, toss it.
Oh.
Look at the table. Because if you use that, that's not going to be an exact value. We're specifically just looking for exact values. Look at the table
1
here.
1 over root 3.
1 over root 3. So that's tan 30, and it says tan squared 30. So we're going to square this, okay? Like that. Minus, again, cos 45. Look at the table.
1 over root 2.
1 over root 2, yes. And that's also going to be squared, yeah? Now think about it. What is 1 over root 3 whole squared? I'll give you a hint. That's the same thing as 1 over root 3 times 1 over root 3.
1 over root 6.
No. What's 3 times 3? It's 9, right?
Oh,
It'll be 1 over 3.
okay.
What's 1 over root 2 whole squared?
1 over 2.
1 over 2, good. Now, is this going to be 0 over 1? Is that right? Because 1 minus 1 is 0, 3 minus 2 is 1.
You have to find the common denominator.
Yes, what's the common denominator between 3 and 2? Just multiply them together, it's 6. So you want to multiply this by a 3, multiply this by a 2. So you get 2 over 6 minus 3 over 6, it's minus 1 over 6, and there you go, that's the exact value.
Okay.
Let's look at D. So that one says 1 minus sine 45 over cosine of 45. What's sine 45?
1 over root 2.
What's cosine 45?
Also 1 over root 2.
Right. What's 1 over root 2 over 1 over root 2? What's x over x? You can look at it that way. What is x over x? And what's a over b of, yeah, exactly. So if you have the exact same thing, doesn't matter how many steps you have, it's 1, okay? So this entire thing is a 1. So, and 1 minus 1 is a what?
0.
0, exactly. And there we go.
Okay.
You understand that? So there we go. That's just, it's pretty, it's just SOHCAHTOA in the table. It's not that bad. And some simple algebra that without a calculator. Now let's take this to the next level. By the next level, I mean, if you look at your grid, right, the graphing grid, there are 4 quadrants, okay? Tell me the point -3, 2. In which quadrant does this lie?
Two.
Yes, -3, 2 is here, right? -3 on the x and 2 on the y, okay? You see this line here? This line is called the terminal arm. The thing that brings you from the origin to the point, that's called the arm, okay?
Okay.
You see this angle here? That goes counterclockwise from the x-axis to that line. That is called the principal angle. And I'm going to denote this. In fact, in most of maths, this is denoted with the letter theta. It's a Greek letter, theta. It kind of looks like a circle, but it has like this thing in there. Okay? It's a Greek letter theta. That means the principal angle. And then there's another kind of angle that brings you from the other side. You see from this side. Okay? And that's called the acute, or in fact, the related acute angle. And that's denoted by alpha, which looks like a fish, the Greek letter A, that is. Theta is the third Greek letter, alpha, beta, theta, gamma, yada, yada. Now,
Okay.
what is this? How does this help us? How in the world does this help us? Let's say your principal angle is 120 degrees. What is your acute angle?
Um, 60.
Correct, 60. Now, how does this help us, okay? And there's a very special property because trig functions, right? Trig functions, they're loopy in nature. The technical term is periodic. That means after a while, it just literally repeats and it repeats and it repeats and it repeats. Okay? It's a repeating function for till infinity. It's going to repeat. So how does that help us? Check this out. What if I asked you, what is the value of sine of 120? We know 120 is our principal angle, right? And the relationship is this. The principal angle is the exact same thing as the related acute angle. So sine 120 is sine 60. And what's sine 60? Sine 60 is root 3 over 2. There we go. See that? 120 becomes 60 because that's what the related acute angle is. Here, let's try another one. 150. So let's say this theta, our principal angle is 150. What is going to be our acute angle? Well, it's going to be 30, no? Because the whole thing is 180. Straight line is a 180, yeah? Straight line is 180. So if this is 150, this must be 30, right? So what does that mean for us? That means sine of 150 is equals to what? Sine of what?
30.
Yeah, which is 1 over 2 and 1 and done. Simple enough? So we're just literally subtracting whatever the principal angle is from 180. But it's never that easy, is it? So now let's add something to this. So the way it works is like this, okay? There's something called the cast rule. Everything we've done so far applies, but sometimes it'll be positive and sometimes it'll be negative. Now, how do you know when it's positive or negative? In the fourth quadrant, only cosine is positive, denoted by the C. In the first quadrant, everything is positive, denoted by the A. In the second quadrant, everything is positive except sine, denoted by S. And then the third quadrant, it's tan T. C-A-S-T, the cast rule. Now let's do that problem again. This was 150. Our related acute angle was 30, right? So sine of 150 is equals to sine of 30. Is sine positive in quadrant 2? Yes, it is, right? So sine 30 is 1 over 2. So therefore sine 150 is 1 over 2. But now check this out. Cosine of 150. We know that's going to be cosine of 30. Is cosine positive in quadrant 2? Cosine is not positive. Cosine is only positive in quadrant 1 where everything is positive and quadrant 4. C, you see that? So that means in quadrant 2, because 150, we landed in quadrant 2, it's gonna, you just gotta put a negative sign here.
Okay.
So cosine of 150 is cosine of 30 with a negative sign. And what's cosine of 30 here? Cosine of 30 is negative root 3 over 2. There we go, like that. Now let's take this up to the next quadrant. Okay, the idea is exactly the same. You just want to see where it's positive or negative. So it's like this. This is 1, 2, 3, 4. And the rule is C-A-S-T. Now let's go into a different quadrant. Let's go here. Our principal angle is 240 degrees. Now we're in quadrant 3, okay? What if I asked you, what's our acute angle? And our acute angle is always going to come from that 180-degree line. If our principal angle is 240, what is our acute angle?
I think I'm confused.
All right, don't worry about it. Let's take a quick breather here, okay? Don't worry too much about it. So let's do this again. You see this one is 150, yeah?
Mm-hmm.
How did you get this as 30?
Because it makes up 180.
Correct, because it makes up 180. It's the same idea in the other quadrant. Look at this. Let's say this is 240, yeah? Where's 180? 180 is right here. So how far is 240 from 180? 60.
Mm-hmm.
You see that?
Uh-huh.
It'll be 60. What if this was 210? What would be a related acute angle? How far is 210 from 180? 30.
30.
Exactly, okay? You just gotta see how far it is from 180. That's all there is.
Okay.
Let's do it for the other quadrant as well, because we haven't done this yet. But the idea is the same. So how many degrees in a circle?
360.
360. If I asked you, this is 300 degrees, what's your related acute angle? How far is 300 from 360? 60 degrees, no?
Mm-hmm.
It's basically the distance. You see that? Pop quiz.
Uh-huh.
Pop quiz time. 215 degrees. Give me the related acute angle. In other words, how far is 215 from that other angle up there, the straight line?
35.
45. Right? Actually, no, you're right. My bad. It's 35. It's 35. Another one. Again, remember, this is 360 here. How far is 310?
50.
Good. Okay. 110 principal angle. How far is the acute angle?
70.
Good. Okay. That's it. That's it. That's all there is. Now let's try doing some more examples in different quadrants, but the idea is exactly the same. I'll do one for you, okay? Let's look at this one. Let's say this is 210. That's our theta, that's our principal angle. That means our alpha is gonna be 30, correct?
Mm-hmm.
Now check this out. Sine of 210 is the exact same thing as sine of the acute angle 30. Is sine positive or negative in quadrant 3? This is quadrant 3, okay? Is sine positive or negative down there? Look at the CAST rule. CAST. Sine is only positive in the second quadrant. Everything is positive in the first. What does that mean about sine?
Not?
Yes, so that means sine must be negative in quadrant 3, like that. So put a negative sign in the front.
Mm-hmm.
So therefore, the exact value of sine 210 is minus sine 30. It's minus sine 30 is 1 over 2. And there we go. Let's look at cosine of 210. Cosine, again, we know that's positive in quadrant 4. It is not positive in quadrant 3. We know 210 is in quadrant 3. Cosine is not positive in quadrant. So there's going to be a negative cosine 30, like that. What's cosine 30? It's root 3 over 2. Therefore, the exact value of cos 210 is negative root 3 over 2.
Okay.
Okay, that makes sense?
Mm-hmm.
Let's see if we can do some questions. That one uses a negative one. I don't really want to use negative. Okay. Let's try doing these guys. Let's go one by one, okay? And for these guys, you may have to use a calculator because for some of them, they don't look like the special angles, but it's not going to change anything. A, in which quadrant does 160 degrees lie? Where's the terminal arm?
The first one?
160 degrees is in the first quadrant? No, it certainly is not. Look at this. First quadrant is, this is 90, okay? See, it only makes a 90 degree. It's not in first. 180. So this one can go up to 180. This one down here is add 90 more to 180, 270, and then loop back to 360. So 160 degrees, it's not in the first quadrant, okay? First quadrant is this one, second quadrant is this, third quadrant is this, fourth quadrant is this. And the rule is CAST, the CAST rule. Now think about it. In which quadrant is 160? It most definitely is not in the first quadrant because you can only have angles from 0 to 90.
Is it in 2?
It is in 2. Good, it's in 2. So our principal angle is 160 degrees. What does that mean about the acute angle?
It's 20.
It's 20 degrees. Good. So that means for us, sine 160 is the exact same thing as sine of 20. Now, is it positive or negative sine in quadrant 2?
Positive.
Good. Now, what sine of 20? You got to plug this into a calculator because this is not one of those nice angles, right? And that is 0.34. And you are done.
Okay.
Good. Let's look at B. That one uses 300 degrees. In which quadrant is 300 degrees?
The fourth one.
Good, it's in the fourth one. So our principal angle is 300. What is going to be our acute angle?
60.
Good. So that means for us, cosine of 300 is the exact same thing as cosine of 60. Now check it. We have to do the CAST check. Is cosine positive or negative in quadrant 4?
Positive.
Good, so nothing changes. Cosine of 60 is 1/2 and you are done. Easy as that, okay? You're getting a hold of this? It's fun, right? Once you start to get hold of it. Math is always fun if you get the right answers. And then when you don't get the right answers, it becomes a chore. Let's look at 110, C. In which quadrant is 110?
The second one.
Good, it is indeed in the second one. So if our principal angle is 110, what is our related acute angle?
70.
70. So what does that mean for us? CAST. Tan of 110 is the exact same thing as what?
70.
Just 70? Tan of 70. Okay.
Okay.
Positive or negative?
Negative.
Good. So negative tan of 70. And again, that's an ugly angle. Ugly angle, I mean, we don't know what the exact value is. It's going to be minus 2.75.
Okay.
Cool. Sine 350. Which quadrant is 350 in?
The fourth one.
Correct. So if our principal angle is 350, what is going to be our acute angle?
10.
10. So sine of 350 is the exact same thing as sine of 10 degrees. Is sine positive or negative in quadrant 4?
Negative.
Negative. And again, that's not a nice number. Sine of 10, and so that's going to be negative 0.17, and you are done.
Okay.
So this is called the CAST rule, used for angles that are above 90 degrees. But the idea is the same. You just find a similar angle, okay? You just find a similar angle. All right, this thing is, we've not done this, but it should be fun. So far I've told you this. If you come from this way, counterclockwise, okay? The angles will be positive. But if you go upside down, let's say you start from this way, okay? The angles will be negative. If you go clockwise, like a clock, the angles will be negative. If If you go anti-clockwise, the angles will be positive. Now, what does that mean? As we'll see in the next question, they want us to find the primary ratios. So in all of these questions, they have given us the related, okay, now we're gonna work backwards, okay? Now we're gonna work backwards. Before we were always given the primary angle. Now here we're given the acute angle and we gotta find the primary angle. Let's go one by one. Let's look at A. Our related acute is 15. What is going to be our primary angle?
175.
165.
Oh, okay.
So 165, okay? Now for B, you gotta be careful. We're coming the other way around. What do you think the answer is for B?
How does it make a difference if it's coming from the other angle?
It just becomes a negative. Just put a minus sign in the front.
So minus 215.
No, that's not going to be minus 315. So we're doing which one? B, right? Look at this. From here to here, if you go this way, yeah? Before in the previous question, we came this way. So if we come this way, it becomes positive 180, okay? If you come from this way, if you come clockwise, it'll be minus 180. But we're not going all the way to this horizontal line. We're stopping right there. So what's the distance from here to here? That'll be 180 minus 55. Yeah. That'll be 125. So this will be negative 125. Simply because we're coming from underneath the x-axis. So it's going to be negative.
Okay.
Okay. Now think long and hard about C. It's also going to be a negative answer because it's going from underneath the x-axis. And the answer is between negative 180 and negative 360. What do you think? We're looking at C. Any ideas? I'll give you a hint, okay? From here, if you go this way to the straight line here, up until there, it's negative 180 degrees.
Is it negative 109?
No, it has to be greater than 180. So from here, yeah, all the way to here, you see that? Up until this point, it's negative 180. And then we got to go 71 more. So it's going to be negative 251. Does that make sense? Because from here to this line is 71, and then from here to there was 180. So that's the opposite of this, right? What will this angle be? Well, if this is your acute angle from here to here, what's the big angle gonna be? It's gonna be 180 plus 71, 251. Same thing, except we're going in the reverse direction. That's why it's a negative. Try D. Now this one will be a positive angle because we are indeed going counterclockwise. We're going up from the x-axis.
Is it 332?
Yeah, that's good. It is indeed 332. Okay. Let's try a little bit. Let's try a couple of more questions, I guess. This is going to be difficult, isn't it? Yes, it is. By difficult, I mean it's just something we haven't done yet. So you see this, they've already given us the ratio. So again, we're trying to work backwards on this, okay? And unfortunately for us, that's not a special triangle ratio, 0.6951. The question here is to find what theta is equals to. Cool? Now we've done this before. It's just going to be cos, second function cos of that number, 0.6951. The answer is 46 degrees. But now we know that there's going to be two different answers because this cosine ratio is positive, right? It's going to be positive in the first quadrant. So this is 46. Where else is cosine positive? Which quadrant?
The second one?
Not the second, not the second. Cosine. C-A-S-T.
Oh, the fourth one.
The fourth one. So that means this angle is 46. Okay? So our other angle is going to be this big angle. What is that going to be? 314. 360 minus that, right? And there we go. So whenever we do the second function or the cosine sine inverse, the inverse functions, there are two solutions. You see that? In fact, there are an infinite number of solutions. But we don't care about those, okay? We just care about the first two. At this level anyways. Before, in the previous level, we were just concerned with the first solution. Now there's going to be two solutions. And eventually, I don't know if we'll get to that, but you'll see that there's an infinite number of solutions. Now, why is that? I'm just going to tell you this. Cosine looks like this, okay? Looks like this. And 0, this up here is 1, and then this down here is -1. Now, positive 0.69 is somewhere here, okay? And you see, when the y value is 0.69, there's an infinite number of x values that satisfy that equation. Okay? So technically there's an infinite of solutions, but we don't care about that just yet. We'll see if we ever get to it. But for us, there's just two types of solutions. All right, let's call it a day there for today.
Okay, thank you. Bye.
I'll see you. Bye-bye.